Welcome back to Rges Algebra 1. This is lesson 1.2. We're starting off with really what we could consider one of the very hearts of algebra, and that is, remember, by the way, a couple of definitions I forgot to mention earlier. Let's say I had, you were learning last time how to simplify or evaluate expressions. Expressions would be groups of numbers and operating symbols without an equal sign. So this is an expression, and you learned how to evaluate or simplify synonyms in that particular case. But in algebra, what we do is we take one or more of our numbers and we replace it by a variable. A very common variable would be x, but we could replace it by any letter of the alphabet. We tend not to use some that could be confusing. For instance, an O could be confused with a 0, so we would not want to use that. But any time, let's say I had something else here, let's say I had a 5 times x. Anytime I have an x in a single expression, this is an expression, no equal sign, that x will stand for the very same value every place you see it. But if I start with a new problem in the single problem, if I start with a new problem, I can change the value of x. So there is not, well, there are some ways to simplify this, but you'll be learning about those later. But I cannot come up with a number answer or value answer like I was able to up here unless I tell you first, can you figure out what this expression would be if x equals whatever? Maybe in this particular problem, I would say x equals 2. Well, what would you do there? By the way, I've used a couple of different expressions here. This represents x times 9, and this represents 5 times x. Well, let's plug in. So I could say evaluate this if x equals 2. So plug in everywhere you see an x, plug in the number 2. So bringing this down, I would go 3 plus 2 times 9 plus 5 times 2. And notice I'm very, very careful to keep all the grouping symbols, all the operations, everything just as I see it, except now I took away every x, and wherever I had an x, I now have a 2. Now I have a problem that you're used to from the last section. So what would you do? You would apply order of operations. So this would be 3 plus 2 times, oops, I don't need the parenthesis now. 2 times 9 is 18 plus, I can go ahead, well, maybe I won't, because that was dealing with parentheses. Now I'm going to deal with my multiplication. This is looks like a parenthesis too, but anytime you see a 5 before a parenthesis or a number before a parenthesis, it means multiply. So this would be 3 plus 18 plus 5 times 2 is 10. Now we're going to add from left to right, 21 plus 10. We're going to add 21 plus 10 is 31. And that's how you would do that. Now this I call evaluation also. For this kind of evaluation, however, when I have a variable, I need to plug in the value of my variable before I can find an answer. We call that plugging in substitution. So let's look at a few more examples. This example says substitute 4 for x. So there's my x. I now want to substitute or plug in 4 and evaluate. First step is always the substitution. Now no longer x but 4. Everything else is what you're used to doing already. Using order of operations, I would need to deal with that first. Now multiply, and that's my answer. The next problem, notice, is the exact same expression, but now it says substitute 9 for x and evaluate. So this time I would have to plug in, every time I see a x, I want to now write a 9. And remember, substitution is your first step. Then you're going to use order of operations. 15 minus 9 is 6 times 3 equals 18. Notice, even though I began with the same expression, how I evaluated whether it's 33 or 18 will totally depend on the number value substituted for the variable. This is a very well-written book, and I definitely want you to read each section. It is covering more things than I'm covering here in the lecture, especially vocabulary that is important, and pay attention to the terms that explain the answers to your operations. For instance, product is an answer to a multiplication problem. Quotient is the answer to a division problem. Make sure you learn those. Now, I want to talk about the idea of parts and whole. If I have a line, a yardstick, whatever it would be, and it represents a length, let's say that represents 8. I could also have part of it. Let's say if I divide it in two, that part represents 3. And this part, I don't know what it represents. Okay. I can make several statements from that picture. I could consider that to represent 3 plus x, the part and the other part, equals the whole. Or I could reverse that, x plus 3 equals the whole. I could also think of the whole minus the part. Let's say I take the whole, which is 8, and I take away the first part. What am I left with? The second part. Or I could take away the second part, and what am I left with? The first part. So anytime you see something that is can be represented as parts and whole, you've got a lot of information. It can represent several relationships, and that's going to be very useful to you when you start thinking about word problems. Right now, you're just being asked to convert written language into mathematical expressions. For instance, the product of 13 and 8 would mean 13 times 8. By the way, multiplication can be written several ways. I could say 13 with a dot. I could say 13 by 8 times 8, but I don't want to use that anymore. Avoid this because of the x. I could say 13 times 8, means the same thing, or I could say 13 times 8. All of those expressions mean find the product between 13 and 8. Whenever we have a variable, let's say I want to say 13 times x, I could either put it with my dot. I do not want to put it with my x. I definitely want to avoid it now because that would make no sense at all to me. I could say 13 times x. I could say 13 times x where I've got a parenthesis around both, or I could simply say 13x with no parentheses, because if you have the number right next to the variable, it means multiply. Now, I could not have done that here, because if I had the number 13 right next to the 8, I would think that's the number 138, not 13 times 8. So you cannot do that. But when there is a variable, there's no ambiguity. Go ahead and work your problems, check your answers, and bring in anything that confuses you to class next time.